So our lab is focused on building robots that sort of, you can think of them as acting like service animals, so helper dogs and service monkeys. And with those type of animals, what we're dealing with is people who have severe motor impairments. So for example, if they drop something on the floor, it can stay on the floor and basically until a service animal or a human caregiver comes and picks it up for them. It can be hours. And then look at it, and it acts basically like a three-dimensional version of a PC mouse. So the robot would detect it and then move over and pick up that object. And then with the same laser pointer, you could point on the floor, on a table, or even to yourself, and the robot would then recognize that and go over and deliver the object either to the location or to the person. And so that was the early efforts. Our more recent efforts have been with RFID. So with a small amount of augmentation, this little RFID tag, the robot can perceive these tags out to about 6 meters in distance using these long-range RFID antennas. So this allows the robot to go into a room and very quickly get a survey of all of the objects it knows about and what actions can be performed on them and how to perform those actions. So for example, we've done tasks like turning on a light switch. It comes up to me, it's going to stop and hand out the object in its hand, the medication bottle. It'll know what medication bottle this is because it's got the RFID tag on it, and then it knows it's handing it to me. And once I grab onto it, it will detect the forces of me grabbing onto it, and it'll release it using these sensors here at the wrist. And then I'll give it back an object, and it'll know the identity of this object based on the tag. So if we can go ahead and have more kit entry here. So here it's following me around using this tag. So you can see the robots, right now it's just, all it's doing is using the difference in the signal between those two long-range antennas. And so if I stop, it'll detect me, and it won't run into me because it saw me with the downward facing laser. So now it's going to hold out the medication bottle. It's hard to hear, but it actually does say that it's the med bottle. And then it tells me I can go ahead and grab it. So if I just apply a little force, it'll open up, and I can get the bottle. And now I'm going to hand it back the TV remote. It asked me to hand it an object. And so it recognized that I handed it the TV remote. And so one of the things that's not implemented yet, you can imagine that now that I've given it the TV remote, it could have for example, in the TV remote database, it could know where to place that object, and it could potentially go and autonomously go and put it away for you.
Here, and you press the button. The robot grab the object automatically, and just you drive it to someone you want to deliver, and hit another button. The robot will zip it up.
Oh my goodness.
Objects, like top 25 objects, prioritized by the ALS. So all those objects are daily objects for thousands or pounds. Just drop it away. Throw it away. And it's unbeatable functionality. For objects that's very hard to pick up by the traditional robot arms, it's just a piece of cake for this robot. Like those little tiny pills or a credit card, maybe not. Yep, grab it. So you know that.
Oh, thank you, robot.
Just the communication.
Perfect.
So basically, as you move that around, now remember, just think your arm is the excavator. It's really sensitive. The trench is right about here, and then you'll notice that the handle rotates. That's going to be your bucket. So you rotate the handle, the bucket to curl and uncurl. No joysticks aren't doing anything now. You're all one-handed there. So you got to curl that bucket and bring it up. Remember, it's just going whichever direction your hands go. There you go. No, you don't do that. That's the goal.
It keeps contracting muscle fibers in my tricep until I grab it, and then it contracts my bicep to move it back. And so we're trying to do that with how we control it and how we design devices that make things move.
So let's see, like Josh said, I showed a traditional Cartesian moving X and Y. But on the end here, I have a set of tweezers that are using this cellular actuators.
Much larger motion at the tips. So that's how it's works.
It's a controller to the local area network right now. My end goal is to actually control it from the internet. So you guys want to
Looks like this is the end of the tour, folks. Have fun.